Hello, Year 7. What is your favorite season and why? What is so special about it? What do you like about your favorite season? Have a quick think. Today, we're going to be looking at the Earth and the Moon phases. This is week 4, lesson 2. The learning objective is to understand why seasonal changes happen. How long is one day? Well, I expect everyone to know this, even from primary school. It is 24 hours. And how long is a year? 365 and a quarter days. Although most people would say it's 365 days. And then we have a leap year because all those quarter days add up to an extra day. And this year, 2020, happens to be a leap year. The Earth spins on its axis, which is tilted at an angle of 23.5 degrees. It is always tilted in the same direction. As the Earth rotates around the Sun, it is tilting on its axis. This causes day and night and the seasons that we experience. I'm going to click on this animation so that you can find out more about the Earth's rotation and its seasons. The Earth rotates about its axis, which is tilted at an angle of 23.5 degrees. In some books, you may see it as 23.4. I believe that's what it actually says on in Kabudo. On the internet, you might find just various slight variations. Anyway, one complete rotation about the Earth's axis takes 24 hours. At any time, only half of the Earth faces the Sun, and this part of the Earth will be in daylight. The other half facing away will be in darkness. As the Earth rotates, it also orbits the Sun. The Earth takes 365 days to orbit once around the Sun. The Earth is divided into two hemispheres, separated by the equator. Why do the hemispheres have different seasons at different times of the year? Well, let's find out. When the North Pole tilts towards the Sun, it is summer in the Northern Hemisphere. At the same time, the South Pole is tilted away from the Sun. What season is it now in the Southern Hemisphere? Well, there's a clue on the screen. And I expect everyone to be able to get the right answer. Of course, it's winter. Well done to those who got the answer. 6 months later, and the Earth is on the other side of the Sun. How does this affect the seasons? The North Pole is now tilted away from the Sun, so it is winter in the Northern Hemisphere. At this time, the South Pole is tilted towards the Sun. What season is it in the Southern Hemisphere? Again, there is a clue on the screen. Now, why do we have different seasons? We're going to look at the first the 4 seasons that we have in the UK. So we have summer, autumn, winter, and spring. So we know that the Earth orbits the Sun while it spins on its axis and it is tilted. Therefore, as the Earth orbits the Sun on its tilted axis, different hemispheres face the Sun at different times. This is why we have the different seasons. How the tilt produces seasons. The first is to do with how high the sun appears in the sky, or how low it appears in the sky. What I would like you to do is to pause the video now and copy the diagram and add the two sun lines, one for summer and one for the winter. While you're doing that, I should explain a little bit more. So in the summer, the sun appears to be very high in the sky and it feels very warm. In the winter, the sun appears to be lower in the sky and it shines in your eyes and it feels a lot colder. In summer, the UK and the northern hemisphere is tilted towards the sun. Because the sun is shining more directly in the UK, the sun appears to be high in the sky. And because it is shining directly, the heat is concentrated on a smaller area, and that is why it is hotter in the summer. But in the winter, the sun is lower and the sun's rays are spread over a larger area. And this causes the temperature to be lower. So the energy of the sun is not as concentrated as it is in the summer. Right, how did you do with drawing the lines? What you should have got is coming up on the screen. So high for summer and low for winter. Now, pause the video again and try and fill in the gaps of the following sentences. There are some keywords for you to choose from. So the first box corresponds to the first set of keywords on the right-hand side. It should take you a few minutes to complete. Did you get them all right? So your answer should have been, the Earth spins on its axis at an angle of 23.4, or in some cases, like I said earlier on, it might be 23.5 degrees. It takes 24 hours to complete one spin. The Earth also orbits the Sun. It takes 1 year to complete one orbit. In summer, the United Kingdom is tilted towards the Sun. This means that there are more hours of sunlight, as we're experiencing now, actually. The sun's rays shine more directly onto the Earth. This means it feels warmer. In winter, the UK is tilted away from the sun. This means there are fewer hours of sunlight. The sun's rays are spread over a larger area. They are less concentrated, and this makes it feel colder. So, can you explain why seasonal changes happen? How would it be different? What would be different if the Earth was not tilted at all? Pause the video and have a quick think. Well, if the Earth was not tilted, we would still be cooler than the equator, but day length and temperature will be the same all year round. Can you answer these extension questions? What causes the seasons? Why are the seasons in the southern hemisphere opposite to those in the northern hemisphere? Why are the days longer in the summer than the winter? If you're struggling to answer these questions, then you need to rewind the video and go through the PowerPoint again. We're now going to look at phases of the moon. The learning objectives here are to explain the phases of the moon and how eclipses happen. The Earth has one moon that orbits the Earth. It is a satellite of the Earth. Now, you've come across that word satellite before in the previous lesson. If you've forgotten, then you need to go back to that lesson. When you look up in our night sky, you will see the moon. The way the moon looks changes during the month. We call this the phases of the moon. As the moon moves or revolves or orbits around the Earth, it looks like it has different shapes. The shape of the moon doesn't really change, it's just its location in space that changes. So let's look at the phases of the moon. So during a new moon, the moon looks dark and cannot be seen at all. As the surface of the moon that we see gets bigger, we say the moon is waxing. Waxing means it's getting larger. So this is a waxing crescent that you can see to your right. When the moon is a quarter of the way around the Earth, it is in its first quarter phase. We see it as half lit. This is a first quarter moon. After the first quarter moon, the moon is moving towards a full moon. We call this a waxing gibbous moon. Notice that the bright part of the moon is getting larger and larger. Now it's time for a full moon. The entire face of the moon that we are able to see shines during the full moon. Following the full moon, the surface of the moon seems to be getting smaller. We call this a waning moon. Waning means something that gets smaller. So this is a waning gibbous moon. Now that the moon is 3/4 of the way around the Earth, it seems to be half lit again. We call this a last quarter moon. Before we get to the new moon again, we see a sliver of the moon shining up in the sky. This is a waning crescent. And then we're back to the full cycle. So we see a new moon again. It takes the moon about 29.5 days to go through all the phases. And when time permits and you're able to go outside, try and remember what phase of the moon that you're actually seeing or observing. We're now going to look at how eclipses happen. Well, I hope you enjoyed watching that video clip. There is another one that I'm going to show you. Okay, in this video clip, there was an experiment that the narrator described, which you can try at home. So you need two very different sized balls, and so a small ball and a large ball, and a torch. It would be easier if you had somebody in your home to help you, so somebody to hold the torch. And then you can try and demonstrate how a solar eclipse occurs and also how a lunar eclipse occurs, which we'll be coming on to soon. So a solar eclipse happens when the moon passes between the sun and the earth, casting a shadow over the earth. The last solar eclipse over the UK was on August 11th, 1999, so about 21 years ago. And they are rare in the UK. A lunar eclipse happens when the earth passes between the sun and the moon, casting a shadow over the moon. Lunar eclipses happen in most years. So, what happens during a solar eclipse? Where must the moon be for a solar eclipse to take place. Now, a clue has been given you in the video, but what I'm wanting you to do is to be able to describe what is actually taking place. Okay, so during a solar eclipse, the moon moves directly between the sun and the earth, blocking the sun's rays from reaching part of the earth. So I didn't want you to say it was just between the sun and the earth, but you needed to talk about the sun's rays being blocked, by the moon and reaching part of the earth. What happens during a lunar eclipse? Where must the moon be for a lunar eclipse to take place? So pause the video now and try and see if you can describe it. During a lunar eclipse, the moon is on the opposite side of the earth to the sun, blocking the sun's light from reaching the moon. Now, these are diagrams that you should be able to recognize. So if you're given a test and you see a diagram here, you should be able to say whether it's a solar eclipse or a lunar eclipse. So this one is obviously a solar eclipse. And for a lunar eclipse, the diagram is different as well. Okay. Before we actually do the plenary, there is a worksheet that I would like you to try. You should be able to download it from Show My Homework. And I would like you to try that first. And after you've done that, I would like you to think on what we've done today. So, what is something that you already know? What did you learn today? What is a question that you could now answer that you couldn't before? And what do you still need to learn? Do you need to go over the video again and remind yourself of some of the things that we have done? Or are you really confident in what we've done today? Bye.